Hi guys. In the previous video, we created the PPI interface, which accept no arguments and it is going to return nothing, but it can perform some functionalities, right? So let me open the code. Okay, so this is the PPI interface which we have created. So if you look at this declaration of this, so it is going to accept not, it is not going to return anything and it is not going to accept anything. So it's a wide. Okay. So let's create another interface which is going to return some data, suppose a uint32. Okay, so some description and then type def. So what is the return type of the function declaration? Suppose say uint32 we are going to return, and which is a type of EFI API to maintain the compatibility between the GCC and the Microsoft compiler. So sample PPI interface underscore 2. Okay, so now for this interface, what is the argument it is going to take? Nothing. So it's a void. Okay. So let's add this entry here. Okay. Sample PPI interface 2. Okay. So we just defined this here, right? So now we need to add the functionalities to this. Okay. So now where are we producing this interface? So if I search for this structure here. Okay. So this is where we are producing the interface, right? So now let me do the split screen. Okay. I will maximize this. Okay. So now the interface which we have created is going to return uint32, right? So now let me type it uint32. So what is the function name? So maybe I can use the same function name. Okay, so here I should type EFI API, should be fine, no issues. Okay, and then you can see here, right? So now the input argument is nothing, but the output data is uint32. So here it's a void, and here from this driver, what we are going to return. Okay, so now probably I will create a uint32 variable as a data, and I will assign this data with a some value called 123456. Okay, and then I will print some message debug info and then BIOS. So I will close this left side windows. Okay, I'll maximize a bit. Okay, BIOS, and then our API get called. I will print it. Okay, and now so whenever this interface is going to call, so we are going to print this message and we have to return the uint32, right? So this is the data. Okay, so let's do return the data, return data. Okay, so now this we have to add the entry to this structure. So comma, I will add the entry here. Okay, so now we created the interface 2, which is not going to take any arguments, but it is going to return some data, which is 123456. Okay, so from this firmware volume PI driver. Okay, so now how the consumer is going to call this function? So earlier, if you remember, we have called using like this, right? So we used to locate the PPI and that pointer will get assigned in this address, and then we can directly call that interface, right? So now the new interface which we have created is going to return some data. Okay, so now let me create a variable uint32, maybe PPI and data I will call. Okay, and now this PPI data I'm going to call. Okay, so the data I'm going to share in the PPI data, right? That a return value. So now I have to call that interface. So sample PPI4 and then the interface name. Okay, and so since it is not going to take any arguments, so it's none. Okay, so now let's try to print the data from this driver. Okay, debug underscore info, some keyword, return value is equal to 0x percentage x new line character, comma PPI data. Okay, so simply what I did, so in the interface I just defined the new type def which is going to return uint32 and which is not going to take any arguments. So that entry I have added to our PPI structure. Okay, and in the producer side, so the same interface I have added here, which is going to return this 1, 2, 3, 4, 5, 6. Along with that, it will print something. So in your case, based on what that PPI needs to expose, you can write the required functionalities here. Okay, and in the consumer, so they are going to locate the PPI. So when they locate the PPI, that the pointer will get assigned, and then we can call that interface like this, and then the return value of from this interface we can store it inside this PPI data, and that PPI data we are going to print. Okay, so let me open this EDK demo. I will open the command prompt, EDK setup. Okay, and then let's do the build. Okay, so let me see if I can maximize this. Properties, font, maybe 24. Yeah. So as you can see, BIOS got builded. I will open the build folder, emulator IA32, debug IA32. I will open the command prompt here. I will run winhost. I will redirect to boot.log, redirect everything. Okay, so it is booted to UEFI shell. I will close this. So let's open that boot.log here. Okay, so it is under build folder I32. Here we have our boot.log. Okay, so now what is the message which we so from this sample driver, right? So here we have some message. Whenever this function get called, we have this entry point, right? So let's search for that entry point. So let me minimize this a bit. Yeah. Okay. So now here, let me do the split screen. So here you can see we are calling this a sample for GUID, which is the interface one, right? So here you can see interface one get called and it is printing some data and the call came back, right? And then here we call this interface two. So inside this interface two, what we are doing, so it should be under the producer. So it should be under firmware value. Okay. So in this, we are defining the data and we are printing that data here, right? So sample interface two get called. So here the same you can observe here. Yeah, here. So sample interface to get called, and then it will return this data which is 1, 2, 3, 4, 5, 6, and then here that whatever the return value we are storing here, and then we are printing the return value which is 1, 2, 3, 4, 5, 6. So this print it is coming from here. Okay. So now let's create the another interface. Okay. Okay. So here I will say type def. It is going to return again, suppose say uint 32. Okay, so now this time I'm not going to use EFI API just to showcase. Okay, so sample PPI underscore interface underscore 3. Okay, and here this time I'm going to take maybe suppose say one argument. Okay, so input. So in I mentioned, right? So in specifies it's an input. It's a completely optional. Okay. So why it is optional? It is not going to do anything. So if I look at the definition of this, right? So it's just hash define in, hash defined out, is just used for indication. So if tomorrow if someone comes and look at this function, right, what this function is going to do, what argument it is going to take, no one knows. So just to make aware that it is going to take these many arguments and this is the input type, so just for indication we use this. Okay, so it is going to take the input argument. Okay, suppose say of a type uint32, suppose say variable. Okay, so it should be round braces. Okay, so now let's add this interface here. So this we are going to call this as interface 3. Okay, so now we have to add the functionalities at the producer side. So in our case in the previous video, the producer is this firmware volume PI. Okay, so now here I will split the screen. Okay, so what is the interface? So we are going to return uint32, right? So uint32 we are going to return. What is the API name? So sample PPI interface 3. Okay. And is this going to accept any argument? Yes, it is going to accept one argument, which is a type of uint32. So input uint32, some variable. Okay. So now, so let's return, let's try to print some data first. Okay. So debug underscore info, some keyword BIOS. Okay. And then let's print this entry. Let's use this /n, new line character. Okay, so whatever the value which they are passing, right? So let's add some, let's multiply that by 2 and then we will return. Okay, so I'm going to return. Okay, so return whatever the input argument which they are sharing, that we are going to multiply by 2 and then we used to return. So let me enclose this within the braces. Okay, so we have to add the interface entry here. Okay, so now from the producer side, so there is an interface which is going to return something and which is going to accept something. So based on that variable, you can decide what it needs to return. Okay. So now in the consumer side, who is going to consume that PPI? Okay. So again, I'm going to create another uint32 variable, PPI2 data. Okay. So now I will call the interface PPI2 data is equal to sample4 and the interface name. Okay. So now if I don't provide any argument, okay, so here you can see there is a underline it is coming, right? So too few arguments. So because this interface is going expecting at least one argument, right? So let's pass, suppose say 1 followed by 3 zeros in a hexadecimal values. Okay, so now this data, whatever it will perform some operation and it will return some data, and that data we are going to store, right? So let's print that. Okay, return value PPI2 data, return value which is this PPI2 data. Okay, so let me build it. Let's wait for a moment. Yeah, meanwhile it this build, right? So our new interface is going to take one argument and it is going to return uint32 value. So it got builded. So I will open the command prompt in the build emulator i32 debug i32. Okay, So winhost redirect to boot.log and redirect everything to greater than &1. Okay, so it got booted to UFI shell. I will close this. Now, if I look at the logs, you can see sample PPI 3 interface, we got the entry, and that entry, the return value, it is doing 2000 hex. So what is the input argument we are providing? It is 1000 hex. What is the output we are getting? 2000 x. Why we are getting 2000? Because from the producer side, we are multiplying by 2. Okay. And then we are going to exit. Okay. So now let's create another interface. Okay. So which is going to return EFI underscore status. Okay. And then sample PPI underscore interface 4. Okay. So here let's maybe okay. So let's take one argument. Let's maybe take two arguments, right? So uint32 variable 1 in uint32 variable 2. Okay. So let's add this interface to our structure. This is sample PPI interface 4. Okay. So it is going to it is going to accept two arguments and it is going to return the status. Okay. So from the producer end, let me do this split screen. Okay. So now what it is going to return? It is going to return the status. So EFI underscore status, and then we have our function name. Okay. And this function is going to take two arguments input uint32 variable 1 comma in uint32 variable 2. Okay. To add this functionality to this, so we can add anything, right? So in this case, what I'm going to do here is, so I will add up these two numbers, whatever they are going, whatever they're going to provide, right? So if it exceeds some limit, then I'm going to return failure. If it is success, then I'm going to return success. Okay. So first I'm going to add up these two numbers. So if variable 1 plus variable 2. So after adding those two numbers, if it is exceeding some limit, suppose say 0 cross some d1000. Okay. So I'm going to return EFI underscore maybe what we can give bad buffer size. Okay. So let me see. Yeah. So it's a bad buffer size. Okay. Suppose say if it is not meeting this criteria, right? So then what we can do? So we can return this success. Return success. Okay. So let's add this interface to at the producer end. Okay. So now let's go to the consumer. Who is this one, right? So now for this, it is expecting two input argument and it is expecting the status as a output variable. Okay. So now here EFI underscore status as suppose say PPI status. Okay. So now I'm going to store that variable here. PPI status is equal to sample PPI interface. Okay. So now I'm going to call this 4. Now here I'm going to pass d1000 as a first argument and 8000 as a second argument. Okay. So let's print the status what it will return. Okay. So PPI status I'm going to print. So to print the status in the EDK2, we can use %R. Okay, and then let's define some other two variables, uint32 data1, uint32 data2. Okay, let's initialize these values to some data. Data1 is equal to 0 cross 10. Data2 is equal to 0 cross 20. So again, let's call our PPI interface. PPI status is equal to sample4 and then our interface name data1 comma data2. Okay, so let's store this value. Okay, let's see what is the status we used to get. So I will build it. Let's wait for a moment. Yeah, yeah. So build got completed. So we'll go to the same directory. We'll run the same command winhost redirect to boot.log everything, and it booted to UEFI shell. I will close this. Now I will open the logs, and here you can see PPI return status bad buffer size, PPI status success, right? So what we did today, so we created three interfaces. So one is interface 2, which is going to accept nothing, and it is going to return uint32 data. And the other interface is it is going to accept one argument and it is going to return uint32. And the other interface is it is going to accept two arguments and it is going to return status based on whatever the operation which we have to perform. And the similar results we observed from the BIOS logs, as you can see here. So it is returning 1, 2, 3, 4, 5, 6, and it is returning the multiplied of that input data, and it is returning the status based on two input arguments. Okay, so that's it for today. Thank you.